Hello, everybody. We are looking right now at the fourth section of our topic 14 notes. We're getting so close to the end of the year, but we've still got about half of this packet left. We're looking at the surface area of pyramids today. And when you hear that phrase, surface area of pyramids, that could actually be referring to two different things. Okay, I want to take a second and talk about both of those separate things. Okay, we could be talking about what is called the lateral surface area. Okay, the lateral surface area would be talking about just the outside parts, talking about just the triangles that go around the outside that come up and meet at one point up on the top of the pyramid. Okay, the lateral surface area is just the surface area of those triangles. It does not include the area of the base. Okay, so whenever you see that word lateral in any of your problems, that word lateral means we're just talking about those triangles. Total surface area would be the lateral area, all of those triangles, plus the base. Okay, so including that part down on the bottom. The other thing that we're going to look at is the two things that are going to be used in all of our formulas today. First one is the slant height. Okay, and we compare the slant height to the zipper on a tent. Okay, the zipper on the tent is on the outside. The slant height is when you go from the top of the pyramid down one of the faces. Okay, yesterday when we talked about volume, we talked about the height of the pyramid being dropped from the vertex at the top straight down to the middle of the base. The slant height is not that. It is not dropped straight down through the middle. The slant height is dropped down the outside, the zipper on a tent. Okay, the altitude is what we called the height yesterday. It's the height of the pyramid. Okay, and we compare that to the tent pole in the middle of the tent that's holding it up. Okay, that's inside of the tent. It goes from the highest peak, drops straight directly vertically down. Okay, and it's different. Now, something that you need to do on your own paper is take a look at this, and you can box it or highlight it or do whatever you need to do. Okay, what I just highlighted, that right down there, 1/2 times P times L. That is how you find the lateral surface area. Okay, the lateral surface area, 1/2 times the perimeter of the base times the slant height, L. All right, so go on and take a look at this first problem here. It's asking us to find the lateral surface area. This problem is nice because it's already done. Okay, all of this stuff over here on the left side, that is the answers. Okay, this is just an example of a problem that is already done. So the first thing we would do if we're trying to find lateral surface area is we would find the perimeter of the base, and then we would find the slant height, and then we would plug them into that formula. Remember that your formula for lateral surface area is going to be 1/2 times the perimeter of the base times the slant height. Okay, so our perimeter, we look at our base. Our base is a triangle, and each side is 8 inches. So we go 3 times 8 to get our perimeter, which is 24. And we look at the slant height, which is 5, and that's the two things that we plug in. So it's 1/2 times 24 times 5. Look at this next one, okay? Problem number 1 right here. Problem number 1, we've got a square down at the bottom. Okay, you can kind of see it, that your square is going to be the base, that area right there that I just outlined in blue. So if we're looking for the perimeter of a square, we're going to multiply whatever the side length is times 4. So 4 times 4, our perimeter is 16. That's the P. The other number, 6 feet. I'll trace that in a different color. Our slant height right here, going from the top vertex down the outside of one of those triangular faces. That's our slant height. Okay, so we plug it into the formula. P is 16, L is 6, so 1/2 times 16 times 6. Our lateral surface area is 48 square feet. Problem number 2. This time we've got a triangular base. I just outlined it in red. All 3 sides are 12, so our perimeter is just 12 times 3. 3 times that side length, excuse me. So P is 36. Our slant height is going to be this 15 right here, okay? You can look at it, and we've got another piece of information, this 10.2, but that 10.2 is extra information that we don't actually need, okay? That 10.2 is the height of the base triangle, and we don't care about the base triangle if we're just looking for lateral area. Okay, if we're just looking for lateral area, we only need the perimeter and the slant height. So that's what we plug in. Our P is 36. Our L, the slant height, is 15. So it's 1/2 times 36 times 15. Our lateral area is 270 square meters. Okay, go ahead and skip over that. Skip over this one. Okay, this time we're going to talk about total surface area. Okay, total surface area is going to be all of the area of the base. Okay, so let me outline our base in blue right here. You can see that our base is a 9 by 9 square. So if we're looking for the area of the base, it's just 9 times 9, 81 square centimeters. Now, if we were looking for the area of just one face, I'll outline it in green. Okay, if we're looking for the area of just the one triangle right there, we've got for the area of a triangle, we know that our formula is BH over 2. The B would be 9, the H would be 7. So when we plug that in, BH over 2, it's 1/2 times 9 times 7. It's 31.5. Now, here's what we have to consider. Okay, and if any of y'all have asked me for help on our Canvas problems that we've worked on this week, you would notice that this is something that I did. What I'm going to do is I'm just going to make a list of all of the different two-dimensional faces that make up this pyramid. Okay, we've got one square on the bottom. It's a square base. It has an area of 81. We also have a bunch of triangles. And the triangles have a base of 9 and a height of 7. And so that means each one of them is 31.5. That's what we just found in those two formulas that I've already pulled back. Okay? When we're dealing with these triangles, there are 4 of them. There's 1, 2 that you can see on the front. There's one on the back right there, and another one on the back side over there. There's one attached to each side of that square. All of them are the same size. So we take that 31.5, we multiply it times 4, and that gives us a total area of 126. Okay, so our total surface area is just the area of the base, that 81, plus the area of all 4 of those triangles. There's 4 of them, and they're all 31.5. So our total surface area is that right there. Okay? The other way that we could do this is something that I want to point out to you right here. Okay? This 81, that's the area of the base. Okay? That right there, when we talked about volume, we referred to that as capital B. And this right here is your lateral area. Okay, so you can do it like this, where you make a list of all of the different faces, but the easier way that we're going to do up next is we are going to look at this problem, and we're just going to add together our capital B, okay, total surface area equals area of the base, capital B, plus the lateral surface area. All right, so let's talk about this one. First off, we've got a pentagonal pyramid. So that means we've got 5 sides going around the base. It also tells us already right here off the bat that the base area is 139. Okay, that right there, that's capital B. I'm a big fan of that because we don't even have to use 1/2 perimeter times apothem to find the area of that base. We can just use 139. Okay, so if we're looking for the total surface area, the formula that we're going to use is this one right here. Lateral surface area, 1/2 P times L, plus the area of the base, capital B. Now, we already have capital B. Capital B was given to us at the very beginning. It's that 139. But for the perimeter of the base, that's something we have to find. The slant height, that's something we're going to have to find, okay? So as we look at our pentagon base, we've got 5 sides that are all 9 centimeters each. So our perimeter is just 5 times 9. It's 45 centimeters. The slant height is that other dimension that's given to us right here in the picture from the top of the pyramid right down the middle of one of the faces. All right. Our slant height is 12. So when we plug this in, we've got our lateral area, 1/2 perimeter times slant height. So that's 1/2 of 45 times 12, plus the area of the base, which is 139. Okay, we just plug in this stuff into the calculator, simplify it all down if you'd like to. It ends up as 409. So our surface area, total surface area, including the base, is 409. All right, this part of it, cross it out on your packet. Okay, this part all uses different stuff. It uses some vocabulary words different than what we are interested in. Okay, it uses some different definitions, some different words that we don't want to use. Okay, because we don't want to get anything confused with what we did in topic 13. I want to instead use this right here. Lateral area. This is the same formulas that are on the back wall. And when you make your cheat sheet, this is what I would recommend you write down. Lateral area equals 1/2 times base perimeter times slant height. And the surface area, total surface area, is that lateral area plus the area of the base, your capital B. All right. That's all we're going to have for this section of notes. Y'all have a good one.